Hey there, I'm Pascal and welcome to another home automator tutorial. If this is your first time, welcome to the wonderful world of DIY electronics with ESPHome. In this series, we are building an over-the-top ESP-based room sensor package using ESPHome. Card to the series above here. If you've seen any of my previous tutorial, welcome back. I know that your time is valuable, so the tutorials has chapters which you can access from the video timeline or in the description. If you want to skip to the meaty stuff, go straight to about the PIR sensor, where I explain why we want to use a passive infrared sensor. In today's tutorial, we will continue to add to our room sensor by adding a PIR sensor to our ESPHome room sensor project to monitor movement and to switch a light on and off using an automation with a little twist. We'll also make the distinction between what is movement or what is presence. If you like this tutorial, please like, subscribe, hit the notification bell. This will enable the YouTube algorithm to present this tutorial to more people. Let's review our hardware and software requirements. I'll leave links to some of the components on my GitHub page. Some of these may be affiliated links, and I will get back a percentage of the sales, but it will not cost you a cent more. Thank you for supporting the channel. For the hardware, we will need a passive infrared sensor. There are various passive infrared sensors, but the specific one that I will recommend today for this tutorial is this one. It's an HCSR501 PIR infrared sensor. There are alternatives. There are mini PIR sensors. However, what I'm hearing is that they're not as precise and as reactive as the bigger one. Software-wise, we'll need Home Assistant and ESPHome. First, let me outline what an infrared motion detection sensor is and the reason we would want to use one. Passive infrared sensors, or PIR for short, are electronic sensors that measure infrared light radiating from objects in their field of view. These motion sensors are commonly used in security alarms and automatic lighting applications. They detect general movement but do not give information on who or what move. For that purpose, an imaging IR sensor is required. PIR sensors work by using a pair of pyroelectric sensors to detect heat energy in the surrounding environment. These two sensors sit beside each other, and when the signal differential between the two sensors changes, if a person enters the room, for example, the sensor will engage. That may mean it triggers an alarm, notify authorities, or maybe just turns on a light. IR radiation focuses on each of the two pyroelectric sensors using a series of lenses constructed in the sensor's housing. In addition to security and lighting applications, PIR sensors are also used in more advanced applications such as visitor presence monitoring and robotics. In robotics, for example, a PIR sensor can be used for movement detection, enabling robots to interact with their environment more effectively. Despite the sophisticated technology behind these sensors, they are relatively easy to use in practical applications. Let's address the elephant in the room: motion versus presence and PIR versus mmWave. Passive infrared sensors and mmWave sensors are both used for occupancy detections, but they function very differently and provide very different information. PIR sensor primarily detects motion by measuring changes in infrared radiation caused by body heat. They are cost-effective and simple to deploy. making them suitable for basic occupancy detection such as motion-activated lighting and security alarms. However, PIR sensors only detect general movement, and do not provide detailed information about what moved. On the other hand, mmWave sensors emit microwave pulses that analyze the reflected signal to detect changes in movement. Unlike PIR sensor, mmWave sensors can be used for static presence detection, meaning they can detect the presence of a person even when there is no movement. Some can also detect multiple persons and provide information about the movement direction of each of these people. This makes the mmWave sensor more suitable for advanced applications such as movement within a confined environment. Where are people going? But also, in the cases of toilets where we do not move much, office or study, or a TV room, where movement may not be evident and cannot be detected by a PIR sensor. The speed of detection between passive infrared sensors of PIR and mmWave sensors can depend on various factors, including the specific sensor model and their configuration. PIR sensors are typically used for movement-activated system or motion-activated systems. They're generally very quick to respond when there is a significant change in infrared radiation, such as when a person enters a room. On the other hand, mmWave sensors emit microwave pulses and analyzes the reflected signal to detect changes in movement. They can detect even the most subtle movements with precision, which may require more complex signal processing and could potentially introduce a slight delay. However, in practical application, both PIR and mmWave sensors are fast enough to meet requirements for most use cases, such as lighting control, security system, and occupancy detection. The choice between PIR and mmWave often depends more on factors like range, accuracy, cost, power consumption than speed. In summary, both PIR and mmWave sensors can be used for presence detection. mmWave sensors provide a higher level of detail and accuracy, whereas PIR detects broader movement and, in my experience, is faster at detecting someone walking into a room. I want to make sure that you understand I will be using both. I found that mmWave sensors are generally slower than its counterpart, the PIR sensor. Today we are adding a PIR sensor. We will add the mmWave sensor to our room sensor package in the next tutorial in this series. About the PIR sensor. As you will see later, the code for the PIR sensor is very simple. You would even be forgiven for thinking it's a copy of the capacitive touch sensor. PIR sensors only have two states. These are sent out to the out or data pin. Motion is detected, bringing us a high, 5 volts. Motion is not detected, bringing us a low. However, the PIR sensor has various onboard settings in addition to its pins. The jumper has two settings. Repeat trigger. In this mode, every motion is detected and the delay timer is restarted. If motion occurs again before the timer expires, the countdown resets. This allows the sensor to repeatedly trigger as long as there is continuous movement. It's useful for scenarios where you want to track ongoing motion or activity, or leave a light on while somebody is in the room. Single trigger. When a motion is detected, the output of the PIR sensor turns high immediately. It remains high for the duration set by the potentiometer, a knob that adjusts the sensitivity and time delay. During this period, any additional motion is not processed, and the timer does not restart. Essentially, it triggers once and maintains the output state for the specified time. In our project, initially we'll use the repeat trigger. Once we introduce a mmWave, we'll use the single trigger. and I'll explain why at that time. There are also two potentiometers. Sensitivity adjustment potentiometer, clockwise will increase the range and anti-clockwise will decrease the range of sensitivity. The time delay adjustment potentiometer, clockwise increases the delay and anti-clockwise decreases the delay. The pin assignments are as follows: ground, out or data, and VCC. Some boards are different. Please check by unclipping the plastic dome. I usually start with the following settings. Single trigger over here, minimum on the time, and halfway on the sensitivity potentiometer. You can tune it from here and decide how you're going to set it up. So here is a typical infrared sensor, or a passive infrared sensor. The first thing that I'd like to show you is that you can clip off the plastic on top. And the first thing that we need to check is the 3 pins, and the order is VCC, out or data, and ground. Now, these are not necessarily always in the same order. I would advise you to check every time. And then we are going to put it back. And I am going to turn it on its side. Here is the trigger setting. I usually put it in multiple trigger when I am testing and building. Then after that, you've got the sensitivity potentiometer, which is halfway, and the timer, which is at minimum. You can tune it from here. You can tune it in whichever way you feel comfortable with. Some need quite a bit of tuning. Others work straight out of the box. As usual, because it's a binary sensor, we can use almost any free GPIO pins. But we will use GPIO 14 for the PIR sensor. I remind you that we are using the following pins already: GPIO 26 for the DHT22, GPIO 21 for the I2C SDA, GPIO 22 for the I2C SCL, and GPIO 12 for the capacitive touch sensor. I will also attach a full circuit diagram on my GitHub page for this tutorial. How about we put all of this together? First, I'd like to introduce you to a little frame that I've built for this purpose. Basically, it's a 3 DuPont plug that goes directly into the PIR like this. And then I just have the male DuPont plugs on the other side. First thing that we're going to do, though, is we are going to switch off the sensor package so that we don't blow anything. So we're going to open again to make sure which one is our VCC, and the VCC is set on the purple. And that's all I need to know. So we are going to plug this into VCC, the purple. Ooh, that was a gray. Okay, so we are going for the purple into the VCC. If it doesn't mind, there we are. Then the middle one is the gray, and that's the data. And the data is going into GPIO 14, and GPIO 14 is a one right after GPIO 12. So it comes, or it should be coming from over here. I apologize for hiding some of it. And obviously the last one is the blue, and that is ground. Assuming again that we can put it into the ground. Come on.
A few moments later.
Okay, so it is now into the ground. So to recap, gray is on GPIO 14, blue is into the negative or the ground, and purple is the positive. We will now use a little bit of tech. As you can see, I've put some here, which I will put over here, and I am going to mount the PIR over here and stick there and switch on the package. Flashes once and it should be online, and it is. So basically we are finished with the assembling and we can move on to some code. I remind you that all of the code is available on my GitHub page for this tutorial. The link is in the description. First things first, we've decided that we were going to use GPIO 14. Now, you will be forgiven for thinking that the code that I'm about to paste is very similar to the capacitive touch sensor. And that's because both use a binary GPIO sensor. There are some differences, and I will be pointing them out to you. So let me go ahead, make a little bit of space. There, we've made a little bit of space. I am going to paste the code and sort out this tabbing there. And there we are. We've got the passive infrared sensor code. I am going to center it in the screen so that we can all see it properly. And as per the capacitive touch sensor, it's platform GPIO. Then we are using GPIO 14, and we are declaring an ID for it. Then its name is movement. The difference here is we are defining a device class as motion, something we never did for the capacitive touch light switch or touch sensor. Next thing we need to do is to save it, and we are going to install it wirelessly as usual. And I'm going to just point out that whilst it uploads, and we'll just have to wait for a second there, you will see that the light, the blue light, flashes. And that's because it's gone into a safe mode and it is uploading, and it is indicating that it is uploading. When it is finished, which is shortly, there we are. We are waiting now for the logs. And it is, yeah, you saw it flash a couple of times. It should have stopped flashing. And that was it connecting back to the Wi-Fi. And here we are. It has started the logs. Movement sending state off, which is a default send for movement. It hasn't picked up anything. Now, let's see if I can trigger it. And there you are. It's picked up the state on, and it has switched the light on. And that's because this is the first time that I record this piece. Okay, so I will see you in the web server section in a second. So we are here at the web server, and we're going to click on visit. It's going to ask us for the username and password, and we know this because we've set it up. And apparently I can't spell admin and my password. Okay, and I'm going to sign in, and here we are. And we are specifically looking at movement in the middle over there. And what I'm going to do is I'm just going to bring my hand on within its range. Yes, there it is. And it picked up the movement. That's what I wanted. And it takes about 10 seconds to actually go off, and there we are. Okay, so we are very happy that's working. We are going to go straight into Home Assistant. So let's go into Home Assistant, and the first thing we want to check is that we are getting the feed of the device through to Home Assistant. So we are going to go to ESPHome on Home Assistant, and we are going to look at the sensor, and movement currently is clear. Let me pass my hand, and yes, it's detected, and it should go off shortly. There we are, and if I pass again, it should see movement. Great, so that's working. So now we're going to go all the way to the dashboard. If the dashboard is a bit different to what you've seen in the past, I have cleaned it up, and all I did is add the light, and the light just switches the light on, as you can see, and switches the light off. It is a very simple card because it is the light card. Let me show you where you're going to find that. You're going to add a card, and if you go a little bit down, you will find the light card. And that's the card that I added. It's very straightforward. You point it to the light, and that's that. Okay, but right now, that's not what we are interested in. Right now, we are interested in having a feedback to see if the movement is detected or not. So I am going to hit edit on our ESPHome room sensor card. I am going to go right at the bottom and move movement and ESPHome movement sensor. Let me try that again. Movement. There it is. ESPHome movement. Yes, that's the one that we're looking for. I am going to drag it all the way up, because I like movement at the top. I'm also going to go and edit it, and all I'm going to do is movement, not movement. I'm going to save that, and we're going to save the dashboard, and we now have the movement inside of Room Assistant. And let me show you, detected. Oh, ECO2 detected. What happened? You see, I break things from time to time too. So I'm going to go and edit this. Where is, oh, I see what happened. Okay, that's fine. We're just going to go ECO2, and there it is. And we're just going to save it. I must have misclicked something somewhere. It's clear, and I put my hand, it's detected, and pretty much that's it. We are finished with the dashboard, and yes, the temperature right here inside the room is 18.8 degrees, and as a matter of interest, it's 16 degrees outside. For us in Africa, it's cold. So I will see you, and let's do an automation. Now that we have the sensor working, we can start with the automation. And all we're going to do is to switch our light on and off. And we'll be using the simulator we built in the last tutorial in this series for the demonstration. But really, you can use any smart switch. The automation YAML will be on my GitHub page, link as usual in the description. What we're going to do is when movement is detected, we are going to take the ESPHome sensor movement, and we're going to set the simulator's light from off to on. After that, we will do the inverse of that in a separate automation. Now, we could do both of them in the same automation, but I don't want to overly complicate things. So let's go to automations, and we go to settings, automations and scenes, create new automations. And oddly enough, you're going to see motion activated light. However, motion activated light only does motion activation of the light. We want to do one step further, and I will show you what I'm talking about in a second. So we're going to create a brand new automation. The trigger is going to be our device, which is, as we know, the room sensor, and we are going to choose ESPHome room sensor movement started detecting motion. So there we are saying, we are detecting motion. To check if it works, it's pretty simple. I'm going to put my hand in front of it and it's been triggered. There are no and if. We're going to go to then do, and we are actually going to put a building block, and you will see why later. Right now, though, all I'm going to do is take an action, and I am going to put the device in, ESPHome device simulator, turn on ESPHome device simulator, simulated light. No flashing, no, none of that. Okay, so what is this if for? If you've got a 2000 watt light outside that you want to trigger with an infrared, do you want that light to come on in broad daylight? In fact, it wouldn't even make a dent, even at 2000 watts. You don't. So what we're going to do is we are going to add a condition, and the condition is device, and we're going to go to the room sensor, and we are going to go to elements below, and I have a little table here, which I will put into my GitHub page for this tutorial, but the recommended values, outdoor is generally about 10,000 lux, indoor near a window about 1,000 lux. In office, we need about 500 lux. In the home, about 150 lux. Now, I can tell you right now that the board is receiving 258 lux. So what we are going to do is, if we fall below 150 lux, we are going to trigger the light. Otherwise, we don't. Now, you're going to tell me how you're going to show this. I'm going to show this to you in a second. So the new automation is going to be called ESPHome movement detected. Okay, save. Now, is this going to trigger the light? So let's check. Let's put my hand through. And movement has been detected, and the simulator light hasn't come on. What have I done wrong? Is it triggering at all? Is below 100. Oh, obviously it won't come on. We are above 150 lux. So it can't come on. So let me switch off my main light that lights me up and lights the board up. Here we are. And I need to wait for about 30 seconds for the illuminance sensor to update. There we are. And we are currently at 44.2 lux. So if I put my hand in front of the sensor right now, it should trigger. And yes, it does. So we are now with a light that works, and it takes about 30 seconds to switch it off.
A few moments later.
It's a long 30 seconds because it won't switch off. I will have to do it manually. Okay, we haven't done the switch off part yet. All right, so we are going to go back and we are going to open a new automation when the trigger of a device, in particular the room sensor, and when movement is stopped detecting motion. Right, then we do not need in this case a building block, we'll just switch it off. Okay, and we're going to paste the device, it's ESP device simulator, and turn on the ESP device simulator. We want to actually turn it off. There we are. To make it wait for a minute, which I like to do a minute or two, what you would do is you would add here 01. We're not going to do that because we are going to waste time if we do that. And I'm going to save it and call it ESPHome movement not detected. And we're going to save this and let's trigger it again. And we are going to trigger it again. And it should switch off shortly, about 30 seconds. There we are. And it has been triggered. Okay, let me put the light back on. And one thing that we need to note is that each time the sensor is triggered, the timer gets reset. So if the timer, if it's re-triggered again inside of Home Assistant, it will just increase the time as time goes by. Now, as I said, about 60 seconds before you switch off the light. There is also another problem that exists. I'm going to switch on the light for you, and we are going to wait about 30 seconds, and it's been triggered. So I switch on the light, and my automation switches it off. I will show you how to overcome that in either the next tutorial or possibly the next tutorial or one a little later. There are ways around that. And I will show you how to do that. Right now, I think this tutorial has been long enough and we are coming to a close. So I'll see you in the wrap-up. Now that we have movement detection to switch a light on and off, we can add presence detection using a mmWave sensor. This is coming in the next tutorial in the series. A little reminder, please like, subscribe, and smash that notification button so you never miss a video. If you want to support the channel a little more, I am on Patreon and Buy Me Coffee. Links are in the description. This was Pascal. I'm signing off and see you in the next tutorial.